Today we are talking about trapezoids and kites, and we want to apply properties of trapezoids and apply properties of kites. So a trapezoid, as we have a figure drawn over here, has exactly one pair of opposite sides are parallel. So we can see from this drawing over here that we only have two sides that are parallel. So we'll draw those parallel marks on our drawing, make sure that that's correct. We have exactly one pair of opposite sides are not parallel. And in that case, those are referred to as legs. So here is a leg, and here is a leg. The two sides that are parallel are referred to as the bases, or the parallel sides are the bases. And then each pair of angles that include a leg are supplementary. And we remember that supplementary means 180 degrees. So if we number all the angles and we say that this is 1 and this is 2 and this is 3 and this is 4, then we can say 180 degrees is equal to the measure of angle 1 plus the measure of angle 4. So each pair of angles that include a leg, so angle 1 and angle 4, both include this leg, so they're supplementary because these sides are parallel. We can also say that 180 degrees is equal to the measure of angle 2 plus the measure of angle 3. That is regular trapezoid. Now we have isosceles trapezoid. And in isosceles trapezoid, we know that all the properties of a trapezoid, so all the ones we just labeled above, plus the legs are congruent. So remember, we said the legs are the sides that are not parallel. So these two sides are congruent, and we still have that our bases are parallel. Then we have diagonals are congruent. And this is only in an isosceles trapezoid. I'm going to put 4 marks here and 4 marks there to show that those diagonals are congruent. And then we have both pair of base angles are congruent. So we have a lot of congruent parts. And we have the base angle. So we have our base angles up here are congruent. And our base angles on the bottom are also congruent. They're not congruent to each other, however. A couple more things to talk about with regard to trapezoid. And we have the mid-segment of a trapezoid, and that is a segment that connects the midpoints of the legs of a trapezoid. So in this case, our mid-segment is this section right here. And I'm going to label this as BM for our equation purposes coming up later. The mid-segment connects the midpoints of the legs. So we have the midpoints of this leg over here and the midpoint of this leg over here. And because our legs are congruent, not necessarily congruent, because this could also be just a regular trapezoid. So it's the mid segment of this left side, and there's 3 congruent marks there. And I can put 4 congruent marks over here to show that that is the midpoint also. The mid-segment theorem of a trapezoid. The mid-segment is parallel to each base and is the average of the lengths of the base. So we already show that these 2 sides are parallel, and we can also add that the mid-segment is also parallel. So we have 2 bases, and the mid-segment are all parallel to each other. And then the thing that we have to be able to calculate is the average. So we want to calculate the average. And remember, we said that I'm going to say that we're going to call that BM for the mid-segment there. And that is going to be equal to the average of the 2 bases. And the things that don't change in the average, in this case, we're always going to add the 2 together, and we're going to divide by 2. So we have base 1, and we have base 2. So the length of the mid-segment is equal to base 1 plus base 2 divided by 2. And next, we're going to talk and apply properties of kites. So kites have 2 pairs of consecutive sides are congruent. So here we can put 3 marks here and 3 marks here to show that those are congruent. And then we can put 4 marks here and 4 marks here to show that those are congruent. One diagonal is a perpendicular bisector of the other. Perpendicular bisector. So perpendicular means that all of these angles intersect at 90 degrees. And bisector means that one of these sides is cut in half, and we can see, or one of these diagonals are cut in half, and we can see that we have a short and long, so those are not congruent. So then we can also show that there's only one pair of sides that are bisected. And it has one pair of opposite angles are congruent. So in that case, those angles that are congruent are right here. And we can also see that these other 2 angles are not congruent.